Hello, everyone. Welcome to another episode of NE Knowscape Podcast. Today, we are diving in one of the most transformative technologies used across a wide range of industries today, membrane technology. From water purification and wastewater treatment to biogas upgrading, pharmaceuticals, food processing, and in many other industries, membrane technology is playing a vital role in managing industrial processes cleaner, more efficient, and more sustainable. Today, to gain a deeper understanding of membrane technology, we are joined by Dr. Debarati Mukherjee, a postdoctoral researcher at North Carolina A&T State University, USA, and a chemical engineer specializing in membrane technology, water treatment, carbon capture, and sustainable materials. With over 8 years of research experience spanning academia and industry, she is passionate about developing innovative solutions for environmental and energy challenges. Welcome to the podcast, Dr. Mukherjee.
Thank you, Dharitri, and the entire NE Membrane team for inviting me to be part of this podcast. And I'm very delighted to have the opportunity to discuss membrane science, which, as you mentioned, is playing an increasing important role in addressing global challenges, especially in water, sustainability sector, and carbon management.
Yes, Dr. Mukherjee. Firstly, we would like to know about your journey. So, to begin with, could you tell us about your journey to membrane science and what inspired you to pursue this journey, this field, and how did your career evolve from industry to academia?
Sure. So, my journey into this membrane technology field began actually during my PhD days, where I was working on water treatment using various like ultrafiltration and microfiltration membranes. So, I was fascinated by how membranes could achieve like high selective separations while consuming much less energy than various other conventional thermal processes. So then I went to IIT Guwahati to pursue my postdoc, where I expanded this membrane application for proton exchange membrane fuel cells. This showed me the versatility of membrane technology across different sectors. Like it was not only limited to water treatment, but it could also be expanded to energy sector. Later, I was working at industry, that is Next Brand India Private Limited, where I was developing like protocols for fabrication of zeolite membranes for gas separation. And the zeolite membranes would be fabricated not from any commercial precursor, but we would be fabricating them from naturally occurring silica, that is from directly from sand mines. So that would definitely reduce the cost and would make the process much more cost effective. Now, returning to academia again, during my postdoc at this USA NCANT, allowed me to combine that industrial perspective gained at NextBrain with the fundamental research in carbon capture and sustainable separations. So today, my research spans membranes, adsorbent catalyst, but membrane science, membrane technology still continues to provide the foundation for many of my research interests.
Okay. Having worked in both a membrane company and as a postdoctoral researcher, what are the biggest differences between industrial R&D and academic research?
Yeah, that's actually a good question. So, what I could gather during my two experiences is basically the definition of success as defined by industry and academia is actually quite different. So, industry, the success is measured by whether a technology can meet performance targets, be manufactured consistently, make economic sense for customers. For in industry, the research timelines are usually shorter and decisions are driven by like product development and commercialization. Whereas in academia, there is greater freedom to investigate fundamental mechanisms, explore different types of materials, pursue high risk ideas that might not have immediate applications. Moreover, I would say that industry emphasizes more on reliability, reproducibility, and the scale up, which is a very important thing for industrial application, and also the market potential of that product, which is not the scale up, and the market potential of the product is not that much studied in case of academic research. So having worked in both environment, like both environment has its own features, and that has taught me impactful innovation requires both scientific curiosity as well as understanding of like practical engineering constraints.
Okay. Now, one of the biggest challenges in membrane science is balancing permeability and selectivity. Also, how can researchers overcome this trade-off?
Yeah, that's actually the most important challenge of membranes. So when I was working in PhD time also, so whenever we used to get a good selectivity, we see that there is a fouling in the membrane and the permeability continuously decrease. So maintaining the selectivity as well as a good selectivity, that is the separation of the contaminants, as well as maintaining a good permeability, is definitely a challenge which has to be overcome for membrane research. So one thing I could say, based on my experience, is the development of people are developing mixed matrix membranes, which are combining polymeric matrices with various other fillers like metal organic frameworks, porous materials like zeolites, to achieve better permeability as well as selectivity. So, moreover, another thing, based on the operation side, based on the performance side, I would say like membranes are being combined with several other pre-treatment processes like adsorption, which are being which basically eliminates the other impurities, resulting in better permeability. So also advanced fabrication techniques are also now being used to develop, like advanced fabrication techniques, I mean the 3D printing techniques, the inject printing technique, which is actually reducing the membrane thickness to several nanometers. So basically we are getting very thin membranes, thin film membranes, which are basically which are trying to eliminate this trade-off between the selectivity and permeability, because the thin film membranes are maintaining a good selectivity towards separation of the contaminants, as well as they are trying to maintain a good permeability. Also, this is the age of AI, and so nowadays data driven materials design and machine learning are also accelerating the discovery of new membrane materials. So I think this is the trend that is going on nowadays to develop, to like to answer your question, to eliminate the trade off between the selectivity and the permeability.
Okay, Dr. Mukherjee. Now, I would like to ask you one question. What are the most exciting recent advancements in membrane technology for water treatment and gas separation?
So so the recent advancements, you mean? Yeah,
Yes, recent
yeah,
advancements.
yeah,
Yes.
yeah. So yeah, sorry. Yeah, I was not able to hear you. Yeah.
No, no, no problem.
So yeah,
Okay.
one of the recent advancements that I was saying is basically the data driven materials, the machine learning, which are trying to which is being designed to try to develop new membrane materials. So so that a large number of membranes can be designed along with their various parameter assessment. So this type of thing is actually accelerating the membrane technology field. Another is also, I would say, repeating the previous question, is the fabrication techniques like the 3D printing and the inkjet printing are also being used to fabricate like thin film membranes, which I definitely would say are the recent advancements in membrane technology, both for water treatment as well as gas separation.
Okay. Membrane technology is widely used in many industries. If we consider gas separation, in gas separation, particularly carbon dioxide capture, hydrogen purification, and biogas upgrading, what technological challenges still need to be addressed?
Yeah, definitely membrane technology, yeah, especially polymeric membranes are now being used for various applications that you mentioned. But still, I think the major challenge is maintaining high separation performance under real operating conditions. Because in real operating conditions, the gas stream contains various moisture and also various impurities. So whenever, as you are saying, like the previous question, that what is the difference between the lab studies, the academic study and industrial studies. So in lab study, we usually do using the gas stream which is simulated gas, like a pure CO2 or like a pure methane. But whenever we go to the real systems, these contain moisture and various impurities. So separation of the gas is of the various gases, CO2 or methane, is basically remains a challenge there. Moreover, the long-term membrane stability is also a very important issue, especially in CO2 rich environments. And uh, and another thing I would say is definitely achieving high selectivity or high productivity without significantly increasing the energy consumption or the operating cost is also a challenge, because obviously for like membrane operation for a long time, we need to see into various factors like reducing the fouling and various other things that definitely require some energy. So reducing the energy is also an important aspect of this work, as I was saying, like the scaling aspect and the fouling aspect. So I think, yeah, definitely that the continued collaboration between various sectors like the material scientists, membrane engineers, and obviously the academics and the industries coming together is essential for the widespread commercial adoption of various lab scale technologies to industrial scale.
Okay, Dr. Mukherjee, you have spent lots of years in industrial area also. So based on your industrial experience, what qualities or performance metrics do companies look for before adopting a new membrane technology?
Yeah. So uh, there are various factors, actually, I would say, that the companies look into for before adopting a particular technology. So to name a few of them, as I know of, are like the stability that I was saying, the reproducibility, the ease of scale up, and obviously the process economics. So they also create, I would say, they care about the permeability and the selectivity, obviously. But these are, I would say, like the part of the evaluation, the characteristics of the membrane. But the first 4 points that I mentioned, I think those are the most important parts our industry would look into if they want to adopt a membrane technology. So the membrane must maintain its performance over like 1,000 operating hours rather than just like 24 hours of short-term laboratory experiments. And the cost, from the cost perspective, the manufacturing cost, the raw material availability, and the compatibility with the existing industrial systems are also very much important considerations for industrial scale, industrial purposes. So yeah, I think these are actually the things that and obviously reproducibility, because if it's not reproducible in various batches, the companies won't accept that thing. So I think, yeah, obviously these are the things that the companies look into while accepting a membrane based system, or while deploying a membrane based system technology in the process. And yeah, I will say that lower, so in general, like a slightly lower performing membrane that is reliable and economical is obviously often preferred by companies over a high performance material that cannot be commercialized. So yeah.
Okay. So what emerging membrane materials or fabrication techniques do you think
Mhm.
have the greatest potential for future industrial applications?
So uh, so coming to the emerging materials, as I know, the mixed matrix membranes, as I was saying. So mixed matrix membrane basically combine the characteristics of the ceramic as well as the polymeric matrices. So mixed matrix membrane, just in a layman term, is like we incorporate some porous materials, like the advanced porous materials, like the zeolites, like the activated carbon, like the metal organic frameworks, into a polymeric matrix membranes. So the membrane is not solely polymeric, not solely ceramic. So it gets the property of the polymeric matrix, and also it gets the property of the porous fillers. So basically, it combines the two properties, and that's why it's called a mixed matrix membranes. So I would say development of this type of membrane is definitely being addressed nowadays, because it could trade off the selectivity. It could eliminate the trade off between the selectivity and the permeability. Moreover, the two-dimensional materials such as like graphene oxide, magazines, these are also coming up as they offer suitable, exciting opportunities due to their transport channels, which can be tuned. But still now the high throughput synthesis of magazine is not yet commercialized. So magazine being in the commercial sector, taken up by the industries for membrane fabrication, is not that much commercialized. Now, on the fabrication side, I would definitely say like the thin film fabrication techniques. Thin film definitely means membrane thickness is less than 100 nanometers, which is a very thin film membrane. And as obviously the membrane people know that thin film membranes offer less resistance to the flow of the fluids, and hence their permeability is higher. So definitely this design of the thin film membranes using various 3D printing techniques like inkjet printing, so additive manufacturing techniques is also being used uh, nowadays, and is also being commercialized, and driven into the industrial sector. So, and also another thing for commercial application and the membrane being accepted in the industry, I think it is equally important, is designing the materials that are inexpensive and scalable, rather than like record breaking laboratory performance. So in this, industrial adoption actually depends on balancing the performance with the ease of manufacture and the cost of the materials as well as the process.
Okay. Now we see that many researchers and students are engaged with membrane technology researches and solutions. So, for young researchers and startups working in on membrane technologies, what are the biggest challenges in translating laboratory innovations into commercial products?
Yeah. So since I have worked in both a research sector as well as in industries, the biggest challenge that I would say is is definitely that the laboratory performance cannot be is most of the time, I would say, not cannot, is most of the time cannot be reproduced at a pilot or industrial scale. So this is the biggest challenge that I would say now, because this is because the researchers in any university or academic systems, they actually focus heavily on designing the membranes based on optimizing the membrane performance, while the things that we do not look into in academia are basically the cost. So the manufacturing cost, the reproducibility, even if we look into the reproducibility, we do not specifically look into the manufacturing cost, the process economics, the techno-economic analysis, the life cycle assessment, and also the ease of scale up. So these are the things that often researchers do not look into. So the startup which is being which is in an initial state, so they also face the similar challenges, which is related to not only related if they take any technology from the laboratory. So one of the challenge that they face is definitely, as I told, like that the commercialization, that scaling of the technology from a research scale to a lab to an industrial scale. Moreover, I think the startups, as you mentioned, the challenge I think that they can face is like funding, the approval, regulatory approval, and also, as I mentioned, which is the most important, like demonstrating any lab scale technology at larger scales. So this is the problem, and as you mentioned, what are the solution that I think that they might have? So definitely, one solution is might be a strong collaboration with industry from early stages can help identify the practical requirements and reduce the developmental risks. Definitely. So another thing, the customer survey, the market of the membrane. So that is also very important to understand. As I have also understood, I was not aware of this aspect. I definitely came to understand this market survey and this customer need of this of any type of materials based on my experience at the industry. So this is important to understand the customer, what the customer needs, the market needs. So rather than just simply developing the materials and assessing its long-term performance. So successful commercialization actually requires combining good science with engineering, business strategy, and market awareness. So that's I would say. So basically, it's all interconnected. It's basically on interdisciplinary. So the startups require definitely some collaboration with academics, as well as some as well as like a good business strategy, as well as market awareness. Whereas the researchers, I would say, if they want their membrane to be to be commercialized, they definitely need to look into some process economic aspects, which would be helpful for further stages.
Okay, Dr. Mukherjee, we are gradually reaching the end of today's conversation. But before that, I would like to ask you, uh, for young researchers and startups working on membrane technologies, what is your advice for them? And where do you see these membrane technologies in future 10 years, next decade? How would you define this?
Yeah. So I think I will answer your the last question first.
Okay.
Like, where do you see the membrane technology in the next 10 years?
Mhm.
Definitely, I think membrane technology is playing an increasingly important role in addressing like various global challenges, not only water treatment, gas separation, but in various other aspects like various organic solvent separation, in desalination. So you name a sector, membrane is there. So there is nothing like membrane is actually widespread. It's fuel cell, it's membranes. Hydrogen production, it's membranes. So there is a lot of sectors the membrane technology is like constantly playing a role. So definitely, in the future, I think the membrane systems will not be a standalone process. It will definitely be integrated with other processes, as I was mentioning, like catalysis, electrochemistry, and also like various adsorption or photocatalysis, and also like the digital process monitoring system, in order to increase their efficiency and also flexibility. So there, it might not be a standalone membrane, it might be a integrated membrane reactor type, which combines the other process that I was saying, so that the process efficiency is also increased, and there might be two applications or three applications might be done in a single system. And as I was also mentioning, and as we all know, like the current system, the current age is of open AI and the and the data driven things. So I also think with the growth of this AI field, I would think that AI and the data driven materials design also accelerates the membrane discovery and optimization. So for students who are now gradually, I'll be coming to your first part of the question. So I would recommend, like, for students who are trying to come into this membrane technology field, I recommend building a strong foundation in the core concepts of membrane technology. Membrane technology is nothing but it's a core chemical engineering. It's a separation process. It's transport phenomena. So I would recommend like building a strong foundation in transport phenomena, in process engineering, in material science, rather than focusing on any particular application, that is a particular water treatment or CO2 separation. So it's a basically it's a chemical engineering and chemistry mixed. So developing like interdisciplinary skills, learning both experimental and analytical techniques will definitely make them more versatile researchers. Finally, I also encourage like young scientists to definitely think beyond publishing papers and consider how their research can ultimately create practical impact on the society. So that I think is the most important thing. And yeah, here comes the startup part that you are saying, because startups are, any membranes is a startup, and I hugely congratulate the entire team for taking such a great initiative, and I wish all the best to their future endeavors. And startups, I, as I was mentioning previously, they also face similar issues like funding, the technology demonstrations at the larger scale. But I would say like for startups, I would definitely recommend collaboration with the larger industries, knowing the market awareness, and also collaboration with any academics. So these are the things that the startups can take up to to make any strategy to commercialize any strategy. So combining good science with engineering, business strategy, and market awareness, that's the main thing that that a startup or a young researcher should take up to make any membrane based technology feasible at a commercial scale.
Okay, and that brings us to the end of our today's podcast session. It was a pleasure speaking with you. Actually, I learned a lot from these conversations actually about membrane technology. And we sincerely appreciate you for taking the time to be with us today. And we wish you continued success in all your future endeavors. Dr. Mukherjee, thank you very much.
Thank you, Dharitri. Congratulations on this exciting venture. Wish you and the entire team of Any Membranes great success as you bring new ideas and technology to the membrane community. Excited to see this. So stay in touch, definitely.
Glad to hear that. Thank you.
Thank you.
And that's how our today's NE Knowscape podcast comes to the end.
Sure.
We hope you all enjoyed this conversation, and we will be back with a new episode with a new guest to you soon. Thank you for watching. Take care.